My name is Kyle Glob.
I'm Dominic Freudenvall.
I'm William Faze.
I'm Rob Kelso.
And our senior project proposal is Basic Utility Vehicle Design Competition. So annually, Elbridge State has been competing in the BUV competition since 2001, and since then it's placed 8 times. The competition seeks to show that low-cost vehicles can be created for third world countries. Professor Martinelli has agreed to be our senior project advisor. So the competition tests the durability of the vehicle and the ability of a vehicle to perform irrigation. These vehicles are great for transporting goods, medical transportation, transporting clean water, and irrigation. The competition this year in 2017 will be held on April 22nd. So a little bit more about the competition. The track that will be the competition takes place in Batavia, Ohio, and teams race on the 2.2 mile track that's down there. And the competition begins by filling up water from a pond. And when your vehicle is fully loaded with water, you race around the track 3 times, dump the water, and then reload your vehicle. And this is done for over the course of 7 hours. It's an all-day event, and you're allowed to carry up to 3 drums of water. And so, a couple of the design requirements. There's the competition specification requirements that covers all aspects of the vehicle. For example, so the max horsepower you can have for an engine is 11. The transmission is up to the builder, but it must have a forward, reverse, and have 2 speeds. The cargo bed and trailer hitch must have a minimum height, and dead man throttle is supposed to be used. Some of the 2017 specification changes are that fuel and oil must be prevented from spilling on the engine, whether it's changing where the fuel line is in the engine compartment. The cargo bed this year, the drums should be easily removed for cargo purposes, and the dead man throttle should be used for safety.
So what we've done so far is we started stripping down the vehicle. We mostly took apart the bed and we started disassembling the pump. We started organizing, or we did organize the shop, and we took inventory of all the equipment that we have that was used in past competitions. We did start designing the vehicle, and we are gonna mostly design the vehicle in winter and finish as soon as possible, so we can start purchasing our materials by the end of winter or very, very early next semester. So what they used last year, they used a Chevrolet S10 frame from a truck, and they decided on using a 3-wheel vehicle or 3-wheel system. And this was because if they used a 4-wheel system, the rules state that if they did, they would have to put a brake system on the front axle and on the back axle. But because it was a 3-wheel system, you only had to put it on the back axle, which reduced the cost and the time required to build the vehicle. They used a Yanmar 9.1 horsepower 4-stroke single-cylinder engine and a Tough Torque T35 transaxle transmission. And we plan on using both of these, the engine and the transmission, in this year's competition because they fulfill our requirements. We are obviously going to have to make modifications to both of these. So this is the vehicle they used last year. And as you can see, it's a 3-wheel system, and the front, they have the drivetrain inside the cage under the seat, and they had the pump system on the side of the vehicle attached to the sides of the frame, bolted onto the frame. And they have the 55-gallon barrels over on the other picture under the skeleton, which made it hard to take off the barrels. and we're gonna have to change that so we can take off the barrels easily during the competition to carry other materials that might have to be transported. So this is what we've done so far. We're gonna keep most of the front the same, so we haven't done much to that. We took off the seat and we have the drive system in the cage still, but we're gonna have to disassemble the cage so we can get to the drivetrain to change it. We took off the barrels and we're gonna have to grind off some of the material in the back of the car so we can change the bed of it. We haven't touched the bottom of it yet to change the suspension, but we will be doing that later on. So we know that we have most of the necessary components to complete this project at Alfred State, but we know we're gonna have to purchase a lot of material to make changes to the vehicle. We plan on using skills like our designing, building, and execution skills that we've learned in classes such as MVP, material science, mechanics of materials, and other such classes to incorporate in making and manufacturing this project.
So we have a series of project goals that we'd like to achieve over the build. One of the goals is redesigning the drivetrain system. Right now the drive shaft is at a pretty steep angle. We'd like to move that a little bit closer to center. We'd like to redesign the suspension system. It's a very crude system. We'd like to improve upon that. We're also going to have to redesign the flatbed area to make it able to store and transport other goods besides the water pumping system. And we're also going to have to redesign the pumping system to accommodate for that. So the drivetrain system, right now the drive shaft is at a very steep angle. This is putting a lot of stress on the U-joints of the drive shaft, which is not ideal because being a vehicle with the intention of being used in a third world country, it's going to have to be very reliable. So with all the added stress on these U-joints, the lifetime of the drive shaft is going to be decreased, which is not ideal because in a third world country it's going to be a little bit more difficult to replace these items. To do this, we're going to have to do all new calculations for the drivetrain system because everything's going to be all moved around and whatnot. So the current layout is pretty much going to be scrapped. Here's a picture of what the current system is like. You can see here that the drive shaft is at a very steep angle. All the belts and all the pulleys are going to have to be moved around. Everything's probably going to get shifted to the left so to bring that drive shaft more center. So all new calculations are going to have to be done to determine all that. The suspension, in past years they've used leaf springs. Leaf springs are a very durable, very robust suspension system. They're capable of handling a lot of weight. So we're going to bring back the use of the leaf spring system. One of the design requirements of this competition is transporting 3 55-gallon barrel drums of water around this racetrack. So that's going to weigh a lot, roughly 1,300 pounds. So the suspension is going to have to be able to handle that, plus the weight of the driver and the rest of the vehicle. One of the other design requirements of the competition is that the suspension must have a 15-inch ground clearance to get over rough terrain, such as like mud pits, fallen trees or branches, and just get through like third world country roads, which are not paved. This is the current suspension system. It appears that they're just pieces of rubber stacked up and bolted together to keep the drive shaft from colliding with the frame. It works. The vehicle will move under the system, but it's a very rough ride. It's a very jarring ride. It puts a lot of added stress on other components of the vehicle. This will also further reduce the longevity of the component lives, which is not ideal in a third world country. So putting in leaf springs will help soften the bumps and whatnot. So all the components will last a little bit longer. It'll be a smoother, more comfortable ride. also going to have to redesign the flatbed area. Besides transporting water, we're going to have to be able to remove the drums easily to transport other goods. This is going to involve redesigning the pump system and creating a quick disconnect system to remove the barrels. In third world countries, they don't transport just water. They're going to have to be moving medical supplies, food items, any various materials that they're going to have to move. So those drums are going to have to come out. So like I said, the pumping system will be redesigned for a quick disconnect system. We're also going to redesign the engagement system for the pumping system because it works right now, but it could be a little bit better. So we're going to try and improve upon that design. This is the current setup in the bed area. These barrels were very difficult to get out, like Dom said. It took us a while. And underneath them there is no bed area, it's just a frame structure. So once the barrels were out, you wouldn't be able to put anything else in there very effectively and carry it around. It would just fall through the frame. So we're going to create a bed system and improve upon all that.
So the time frame for our project is that we have a strict deadline. The competition is on April 22nd, so our vehicle needs to be completed and in Batavia, Ohio before the 22nd. So our plan is to be completed with designing and building the vehicle by the end of March, which gives us 3 weeks of time, which we feel is plenty enough time that if there are any delays in the building process, that gives us time to correct anything that needs to be done. Because of this strict deadline, we need to be completed with the BUV by that date. It needs to be ready for the competition by then. So because of this, we will prioritize the design and build. So our main focus will be on the drivetrain and pump engagement system for the BUV. We plan to spend the most time on this and feel that it is the most necessary and most important part of our build this year. Next, we will focus on designing and building a working leaf spring suspension system to replace the rudimentary suspension that's on the BUV right now. This is also something that we feel is fairly important to the build. And third, we'll focus on building a more efficient and effective flatbed system that can be used for everyday purposes as well as just hauling around the jugs of water. The funding for this project comes from a grant through Alfred State that is specifically for the BUV competition that is for up to $2,000. One of our biggest expenses for this build will probably be the leaf springs, which could cost up to about $100 per spring. In addition to this, we need to keep in mind the cost of traveling to Batavia, Ohio, and back for the competition, and all of the associated costs with that travel for the competition. In addition, potential cost is rebuilding the rotary pump. It took some damage due to debris in last year's competition, and it could be an issue for us, but we have enough funding that we should be able to rebuild that if we need to. A variable cost for our project is structural metal. We are unsure right now of what exactly we need for that. Until we complete our design, we won't have an exact figure for the cost for that. As for the tools we will use, most of what we will need is already owned by Alfred State in our lab, such as welders, grinders, and other standard tooling. Alfred State has a long legacy with the BUV program, and a history of success in this event. As Will said, this dates back to 2001, and especially recently, the Alvin State BUV teams have been very successful. In the past 4 years, the Alvin State team has finished in third or better each year, and last year they even tied for first place. We hope to build upon this success and represent Alvin State well and represent the education that we are getting here well. And hopefully use a lot of what we've learned in our 4 years here in the design and build of the BUV, and hopefully gain valuable knowledge along the way and experience that we can take into the workforce.
Thank you for considering our project, and we hope that you accept our